In previous classes, just we have discussed regarding to the Biot-Savart law and Ampere circuit law, and even the current carrying wire to do that current carrying wire. What is the magnetic that also we have seen. And let me start some applications based on this due to current carrying circular coil and based on Ampere circuit law and even Biot-Savart. So let me discuss. And we have seen some formulas based on this one also. Just we can go through the previous classes. And let me start some application based on these topics. This is what first one we are discussing. See that in this question they have been shown that 48 one, this is some area. ABCD is a square of side L. Is it? ABCD is a square of side L. ABCD is a square of side L. But they didn't give that it is carrying current, so it is not carrying current. A very long straight conductor carrying a current I passes through the vertex A. So through this one, a very long conductor like this, very long straight conductor. Okay, passing through this one, perpendicular this plane, not along this one, but for this plane it is perpendicular. Okay, so let me take for example, if it is Y is carrying current, if it is inward, let us take inward. Cross represents carrying wire is inward. Is it okay? The minimum magnetic induction at a vertex of a square. Minimum magnetic induction at vertex of a square. At vertex of square. Okay. Now let us see. Here these sides of square not carrying current. Only this wire is carrying current. Now, due to a current carrying wire, what is magnetic field at a distance? If due to current carrying straight wire, what is magnetic field if you have taken like this? Now, it is some distance r, that's infinite, this is what infinite. Then B is equal to mu naught by 4 pi into I by r. So, actually we know sin theta 1 plus sin theta 2, that is sin theta 1 plus sin theta 2, but theta 1 and theta 2 is equal to what here? 90 degrees. Theta 1, this one, theta 1, theta 90 degrees. That is equal to mu naught by 4 pi I by r into 2. This actually we know this expression. Now they are asking minimum magnetic induction at vertex of a square. Minimum. At what point? So here we have like at this vertex or at this vertex or at this vertex. At what vertex of this square the magnetic induction is minimum. So look at this one. R known here. B is inversely proportional to R. That represents at more distance, at longer distance, at larger distance, the magnetic field is minimum. So at what here L, here L, but this C is at large distance. Then what is this value? R is equal to root 2 L. Okay? At long distance, B is minimum. So that is R is inverse, B is inversely proportional to R. Therefore, at C, B is minimum. At C, vertex C, B is minimum. That is equal to mu naught by 4 pi I by R into 2. Let us say. But remember here, R is nothing but what you know, root 2 L. Mu naught by 4 pi I by root 2 L into 2. That is equal to mu naught by 4 pi I by root 2 L times root 2 times, that is equal to L into root. So So this is what we have. That second option we have mu naught by 4 pi root 2 I by a. So let me go to next one. 49th one. The magnetic field at the center of circular loop in the circuit shown below. We need to find for this one. So this is a circuit, that is what we have one loop circular coil carrying current, right? Even the second also carrying the same current. But let me remember that the magnetic field due to a circular coil, magnetic field at center of a coil carrying current B is equal to mu naught by 4 pi into I by R into theta. Means instead of coil, the center of a arc if you have taken. So you can find, if you remember for this one, you can find for any semicircular circuit whatever. So theta is for circle means what you get for coil, what you get B1, let me write B1 is equal to mu naught by 4 pi I by R into, for complete circle what is that, 2 pi. 2 pi. Okay, we found the magnetic field due to this current carrying coil, but what will be the direction? To find the direction of the magnetic field, just you need to know the Ampere's right hand. So, if thumb indicates the direction of the current, third fingers indicates the direction of the magnetic field, and vice versa. Means if the third fingers indicates the direction of the current, then thumb indicates the magnetic field. So let me use this one. Now look at this. At center we need to find, at this point now we need to find, at that point we need to observe the direction of the finger. So just I am taking right hand. You place in the direction of the current, in the direction of the current in a circular coil. So it is like clockwise. Then thumb, what is the direction of thumb? Inward. So let me write here. Cross reference what na? Inward. Inward. Similarly, due to this here we have, this is first one that we take, and this is second one. That means at this point, due to this circular coil we will be having magnetic field. Even due to this current carrying wire also we have magnetic field. So due to straight wire magnetic field B2 is equal to, so just we have written here what is this magnetic field, mu naught by 4 pi into I by R, because this distance is what na R, mu naught by 4 pi I by R into 2. Okay, then what will be the direction of the magnetic field due to this straight wire? Again, you take your right hand only, place your thumb in the direction of the current. So for this right wire, in the direction of the current. Then at this point, go at that point. What is the direction of the fingers? Outward. So the direction of the fingers is what? Outward. Dot represents what? Outward. Then this direction is outward. Therefore, resultant magnetic field. What is resultant magnetic field here? So resultant magnetic field is B1 is inward, B2 is outward. Then B is equal to B1 minus B2. So let me write mu naught by 4 pi I by R. Mu naught by 4 pi I by R into 2 pi minus 2. For this also I by mu naught by 4 pi I by R is common. So what we get here? Mu naught by 4 pi into 2, you can take down 2 I by R into pi minus 1, which we have. This is second option will be the answer. Let us see 50th one. A current of 1 ampere is flowing in the sides of equilateral triangle and given side length. You need to find the magnetic induction at the centroid of the triangle. Okay, let us see that. Now we know already, due to one end, one wire, what is the magnetic field? You know this. Is it if it is R, and this is the length. Side length is given here. The triangle is given. If it is theta 1 and is what we will form. But as it is an equilateral triangle, so what will be this value? Here it is total 60 degrees means this is 30 and this is 30, but theta 1, theta 2 are 60 and 60. That is theta 1, this is 60 degrees and it is also 60 degrees. But what about this R value? From here we have R value, which is it divides in the ratio of 2:3. Is it? Then this value is L by 2 3. R value is nothing but L by 2. Now first we find for due to 1 end, then we will get for due to all others. So due to 1 end, one side, due to one side, let me write. That is equal to B is equal to mu naught by 4 pi I by R into sin 60 plus sin 60. That is equal to mu naught by 4 pi into I by R is nothing but L by 2 3. Say L 2 root 3 I multiply into sin 60 root 3 by 2 plus root 3 by 2 to root 3 by 2 and this value is root. So what do we get here? Therefore B1 is equal to mu naught by 4 pi I by L into 2 root 3 into root 3 6. Remember this is only due to one side, but what about remaining two sides? They will be equal. Both all magnitudes are equal. That means because of the same sides, silent but we need to see that magnitudes are equal, but what will be the directions? That is very important. Look at this again. We can use right hand rule. This is due to this one at this point in what, and due to this one at this point in what, and even due to this one currently thumb is in the direction of the current, fingers in the at the point in what. So all B1 and B2 and B3 all are in what direction? Therefore resultant magnetic field is equal to what? B is equal to B resultant is equal to B1 plus B2 plus B3. That is equal to 3 into all are equal mu naught by 4 pi into I is 1, L is equal to known 4.5 into 10 power minus 2, 4.5 into 10 power minus 2 into this is what? 6. Is it? Now you can see here 3, 1.5 times and here it is 4 times. That is called mu naught by 4 pi minus 10 power minus 7 into 4 by 10 power minus. So 10 power minus 4 is 10 power plus 2. Then 4 into 10 power minus 5 Tesla is the magnitude at this point. Okay, at this magnitude, what is the direction? Inward, rough, which is inward. At that point, it's centroid. So just for the first one, second one, third one, 2, 3 inside. That is what. First option is the correct one. Similar as let us discuss next one. So this is what the 51st one diagram is given that. Let us check the answer. So here given. So let us discuss. AB is one straight line and BCD is a semicircular path and D is a again straight line. Now due to these three paths at this point rho we need to find magnitude. Is it okay? First due to what AB at O. So let us take 1, 2. Now, if you have taken this point O is along the axis of the point AB, therefore magnitude is what? 0. Is it? Next, due to this point BCD, due to semicircular Y, BCD at O, which is let me take B2, that is equal to. So for semicircle, what is the mean? Pi. We know already. Mu naught by 4 pi I by R into what is the mean? Theta is nothing but pi. Okay. Then what will be the direction? Is it okay? So just we which is outward. So you can represent the ground. Similarly, if you have seen the part DE, so this is a current carrying straight wire for this DE, yet one end of the wire due to DE at O, which is at one end of the wire, is it? Now let me take here this O, this is 1, and here it is D, and here it is E, like this we have. Now what you can observe, theta 1 is equal to 90 and theta 2 is equal to what? 0. Theta 1 is equal to 0 degree and theta 2 is equal to 90 degrees. At one end of the wire magnetic field B3 is equal to mu naught by 4 pi I by R into, because from here to here the distance is nothing but radius only. Now what is the value? Sin theta 1 0 plus sin theta 2 sin 90. That is equal to mu naught by 4 pi I by R into 1 plus 0 1. Is it? So what we can write? Even you can cancel this pi also here. Mu naught I by 4 R. So this is the second one. Outward. So then what is the direction of magnitude due to this one? Current carrying by thumb and third finger which is outward. Then this is also both are outward only. Then resulting magnetic field is what? Resulting magnetic field B is equal to B1 plus B2 plus B. Now this is 0. It is outward only, so that we can add mu naught I by 4R plus mu naught by 4 pi I by R. That's all. Because all are the same direction, we have added, and options are given in terms of the same. Then direct answer mu naught I by 4R plus mu naught I by 4 pi R is the answer, which is the third option.
Let us see 53rd one. Two identical coils carry equal currents, have a common center, and their planes are at right angles to each other. The ratio of magnitude of resultant magnetic field at the center and the field due to one coil we need to find.
Now let us see that two coils are carrying current. Equal ones have common center and their planes are right angles to each other. So this is in this board plane, means one more coil is like this. Then you need to find the resultant magnetic field at the center and the field due to first let me write field due to one coil, field due to one coil at center B is equal to mu naught. So this is as it is a circle, what is naught? Mu naught by 4 pi I by R into 2 pi, which is nothing but mu naught I by. So directly we can cancel it. Is it? Same as that, even B1, and that is equal to, both are having same values. B1 is equal to B2. That is equal to B. That we take because same current, same radius, and same current, same radius, these remain constant. Then both are having same magnitude. Magnitudes of the magnetic field. Magnitude of fields. Magnetic fields due to one coil, each coil at center. Each coil at center. Okay? But let us see the direction. What would be the direction? Look at this. So we have one coil in this plane like this. If we have taken on the floor, now that is carrying current like this. That is carrying current like this. Means what would be the direction of magnetic field? Let me take, if it is 1, it is coil 2. The first coil the magnetic field is upward. Then let me take here B1. Similarly, if you have taken, let me take, if you have taken a ring like this, if you have taken a ring like this, is it? Now it is carrying current in this direction. Is it okay? Now what is the direction of magnetic field? Like this, towards this direction. Is it okay? Now B2 is in this direction. So look at this. For first one like this we have, then current is in this direction, then outward, upward, and due to this one current carrying in this direction, like this we have this direction. Now if you observe clearly, B1 and B2 are perpendicular to each other. B1 is perpendicular to B2. Then what is theta? 90 degrees. Then net magnetic what? Net magnetic field B resultant BR is equal to root over, we know already, B1 square plus B2 square plus 2B1 B2 cos theta by using vector. Theta is 90 degrees, cos 90 0, that is equal to, even B1 and B2 are equal, then B square plus B square is equal to root 2B square, that is equal to root 2B. Now they are asking the ratio of the resultant magnetic field to the one of the coil. The ratio of B resultant by B is equal to root 2B by B, that is equal to root 2 by 1. Therefore, root 2 is to 1 is the answer.
So uniform wire of resistance 12 ohm is bent in the form of a square. A cell of EMF 6 volt is negligible resistance connected across the diagonal of the square. The magnetic induction at its center is.
So look at this one. We have at this point O we need to find. Then as totally 4, let me take A is equal to 4 N, then 4 parts, it is having resistance 12 ohm. For A square we need to have the same L 4 N total. Even the resistance is directly proportional length, then this is 3 ohm, 3 ohm, 3 ohm, 3 ohm. Now if you are asking that these two are in series, these two are in series, therefore the current will be divided equally. So I here also the same current will be divided. I. And if you observe clearly, the magnetic field due to each at this center is remains same. That we know already. If you have seen, this is let me take one and I, and at this point O, and this is here 45 degree, here also 45 degree. If it is 90 L, then R is equal to what? L by 2. R is equal to L by 2. Then B is equal to what? B1 is, all are having same magnitude, same length. Then what you get? Mu naught by 4 pi I by R. R is nothing but L by 2 into sine 45 plus sine 45 is equal to what? Mu naught by 4 pi I by L by 2 means 2 by L into sine 45 plus sin 45, 1 by root 2 plus 1 by root 2, 2 by root 2. Then 2 by root 2 means root 2 due to each one. Okay, but we need directions. We have taken, let's take 1, 2, 3, 4. B1, look at this one, direction at this point, outward. B2 also outward. B1 and B2 are outward. Same time, same magnitude. Then B1, B1, B2, B3, B4, all will be having same magnitude. Okay, next. But due to this fourth one inward and due to this third one also inward, then B3 and B4, which is inward, both will be inward. Then what is resultant magnetic field? Resultant magnetic field B is equal to B1 plus B2 minus B3 plus B4, that is equal to 2B minus 2B, that is equal to 0. So first option will get resultant magnetic field is 0 at take center.
Next one, 56th one, a circular coil of radius R having N turns carries a current I. The magnetic induction at the center of the coil is B. Now the coil is unwound and rewound with the half the original radius. If the magnetic induction at the center of the coil is to be the same, the current that should be passed through the coil.
See that? The circular coil of radius R having N turns carrying a current I. The magnetic induction at the center of the coil is B. So let us see what is the magnetic induction at the center of the coil. Magnetic induction at center of coil. So just I have explained in previous classes like B is equal to mu naught Ni by 2R, mu naught by 4 pi I by R into 2 pi per n. So you can write B is equal to mu naught Ni by 2R. Now remember, they given magnetic field is same and mu naught value is constant, 2 is constant, but in this case L1 is equal to N times and I1 is equal to I, R is equal to R. But in this case the radius R2 becomes R by 2. R2 becomes R by 2. Rewound. How y is now made it into one circular form N. But now it is rewound. Now, what current should have passed through this loop to have same magnetic field? That is what. Then let me write here I is directly proportional to R by N. From this one, I is directly proportional to R. Let us remember. But remember, the length of coil is remains same. Length is remains same is what you can write? N1 R1 is equal to N2 R2. Remember that one. The number of turns are here N means, but the number of turns may not be equal. That we need to find here. Is it? Now, N into R is equal to N2 into R2 is nothing but R by 2. Then R cancel. N2 is equal to 2N. That is very important thing. Therefore, I1, I2 is defined. I2 by I1 is equal to R2 by R1 into N1 by N because N is inversely proportional to I. Then I2 is equal to R2 is nothing but R by 2 by R into N1 N by 2N into by I. N cancel, R cancel. Then I2 is equal to I by 4 is the correct option, which is fourth one is correct option.
This is the diagram given. They are asking the equation of locus of points of zero magnetic induction for two long straight current conductors.
So if you are seeing this wire is not in contact with this one, now you can understand. Locus of they are asking to find. What are they asking? The equation of locus of points of zero magnetic induction means x and y. Zero magnetic induction. Now look at this one. For example, due to this one, at a distance x, what is magnetic field? B2 is equal to mu naught I2 by 2 pi into x coordinate x. But due to this one, at a distance along this one, at y, B1 is equal to mu naught I1 by 2 pi 1. To have zero magnetic induction, then what? B1 must be is equal to B2. Is it? B1 must be equal to B2. So what we can write here? Mu naught I2 I1 by 2 pi y. So why we have to take y? For I1 at a distance y, you will get magnetic field. That's what. And even directions are important. So due to this I1 the magnetic field is outward, whereas due to y the magnetic field is inward. Then equal to opposite direction, then you will get resultant magnetic field is 0. Similarly, mu naught by 2 pi x into I2. Mu naught by 2 pi, mu naught by 2 pi cancel. Now I1 by y1 is equal to I2 by x. From this one, y is equal to I1 x by I2. I1 x by I2, which is third option is the correct.
Stick 62nd one. And this is the shape given. We need to find value.
See that here we have the current carrying wire which is having different shape. Due to this at point O, we need to find the resultant. Now you take AB is one wire, BC is one part, CD is one part. At point O, due to AB, Y, due to Y, AB, due to Y, AB. So this is what Y, AB. Let me take it is 1, it is 2, and it is 3, third part. What is magnetic field? At O, B1 is equal to, you can observe this point is along the axis of this wire, therefore 0. Along the axis of the wire, the magnetic field is 0. Similarly, due to part BC or which is B2 is equal to, due to any arc of the length of the wire, the magnetic induction is B is equal to mu naught by 2 pi r into angle. That means here angle of arc is pi, then mu naught by 4 pi into I by r into alpha. Alpha is the angle. Students, you need to know the direction there. Due to this one, what is the direction at this point? Outward. So this is what outward. Magnetic field is outward. Similarly, due to y CD, for this y CD, this point is along the axis, therefore B3 also 0. Therefore resultant magnetic field at point B, at point O, field at point O, B is equal to B1 plus B2 plus B3. That is equal to B1 value is what? 0 plus mu naught I by 4 pi into this value is given R. That's what we have, capital R is given in diagram. Then R into alpha plus 0. Then mu naught I by 4 pi r into alpha. Alpha is given first, which is second option is correct.
B is a magnetic induction at the center of circular coil of radius r carrying current I. Then its value at a distance of root 3r on x from the center of the coil we need to find.
See that at center is given, at center is equal to 1 Tesla. At a distance B, at point P, at a distance which is at a point P, which is x value is what? X is equal to root 3r. What is magnetic field we need to find? But remember, what is the magnetic field induction at center? B at a point B is equal to mu naught Ni r square by 2 into r square plus x square whole power 3 by 2. But at center value is what? At center magnetic field is B is equal to mu naught Ni by 2r. Mu naught Ni by 2. So let us take ratio, then magnetic field at point P by magnetic field at point at center. So take ratio, you can mu naught Ni cancel, 2 cancel. Now if you take this r will be reciprocated, then r by I you get. So r cube by r square plus x square whole power 3 by 2. But remember, x is equal to what is given? Root 3 small r. So root 3 r, the given radius is r. So let us take according to this small r is the radius. That is equal to r cube by r square plus x square root 3 r whole square. Root 3 r whole square whole power 3 by 2. That is r cube by r square plus 3r square whole power 3 by 2. Is it? Now what we get here? Magnetic field at point P by at center is 1 Tesla. That is equal to r cube by 3r square plus 3r square 4r square whole power 3 by 2. 4r square whole power 3 by 2. That is equal to r cube by 4r whole square means 2r square 2r whole square whole power 3 by 2 means square this 3 by 2 cancelled and 2r cube whole cube. That is equal to 1 by 8. Then manipulate the point P is equal to what? 1 by 8 Tesla. 1 by 8 Tesla, which is what option you get? First option is correct.
So a thin insulated wire forms a spiral of N is equal to 100 turns carrying a current of 8 milliampere. The inner and outer radii are equal to A is equal to 5 centimeter and B is equal to 10 centimeter. Find the magnetic field at the center of the coil.
So for this, just we need to see what they have given. A thin insulated wire forms a spiral. This is a spiral. Yes. Okay. And it is carrying a current. Now they are asking to find the magnetic field at the center of the coil. At this point, at the center of the coil, what is magnetic field? But remember, it is a spiral, so it go on increasing. It goes on increasing. The radius goes on increasing. But we don't know. Even they have given inner and outer radius is given 5 centimeter and 10 centimeter. First, we find for a particular length what will be the magnetic field center. Thereafter we can apply this one. Is it? So let us find let N be the total number of turns. Total turns. Okay. If N is the number of turns per unit length. Number of turns per unit length. Unit length. That is N is equal to N by what length they are asking from inner radius A to somewhere outer radius B. Let us take then B minus A is the length of this. Okay. But we don't know what is magnetic field at center to this spiral. For that purpose, let us consider at a distance x. At a distance x, let us take dx part of the ring. Dx part of the ring. At a distance x from this spiral, we consider dx part of the dx thickness of the spiral. So which is at a distance x from it. Consider dx thickness of ring. Thickness of ring at a distance x from center. The distance x from center. Then what are the number of turns within this thickness? Number of turns within that. Number of turns within dx length is equal to what? N dx. Number of turns per unit length into thickness of it. Now, due to this dx coil at center, now due to this coil, magnetic field at center, magnetic field at center, what is magnetic field at center? B is equal to what is the formula? Means dB because due to dx part of it. Mu naught by mu naught Ni by 2r. Mu naught Ni by 2r means mu naught into N dx I by 2x. 2x because the length from here to here is what? So let us find. But therefore total magnetic field from where inner radius to outer radius means A to B. Then B is equal to integral dB, limits are from A to B. Yes, please answer this ones. That is equal to integral dB. dB is nothing but what you know? Mu naught N dx I by 2 into dx by x, limits are from A to B. So mu naught and A by 2 is common. Mu naught Ni by 2. Integral dx by x is nothing but what? Ln x log x log bc x ln x Limits are from where? A to B. That is equal to mu naught. N value is nothing but what you know? N by B minus A. Is it just N I by 2 into B minus A? And this value is what? Ln upper limit minus lower limit. Ln B by. So this is what the magnitude, total magnitude into entire spiral from it. Now you can substitute values. N value is given 100 times. I is given 8 milliampere. A is given 5 cm. B is equal to 10 centimeter. Okay. Just mu naught value is 4.10 power minus 7 Henry per meter. So all values you can substitute. Just to substitute and calculate, and you would get this value as 6.92 10 power minus 6 decimal. Just to substitute values and calculate, we get that answer 6.9 10 power minus 6 decimal. This is for spiral because we need to follow this method. Just how to find due to a spiral which is carrying current magnetic field at center. This is the method to find. So please students practice these problems based on which we have seen for magnetic current carrying coil or a straight wire, even based on Ampere circuital law or Biot-Savart. These all applications. Please follow this and practice perfectly so that you will get the knowledge how to solve these problems based on this concept. Thank you everyone.